Hey guys, this is JSer. How are you doing? I'm making these videos to prepare my interview next month from Facebook. It's a front-end positions. So besides algorithm problem, I still need to prepare for like questions about JavaScript, CSS, about HTML, browser, anything. I found that JavaScript.info is really a good reading material. So in this video, I'm going to spend some time on prototypes inheritance. I know about it, but honestly, I didn't really read the details of how things work. I hope that in this video and I could understand better about prototypes. Not understand it better, but I so I hope that I could explain these concepts very well during a real interview. So yeah, thanks for staying with me. There are four articles about this concept prototype. So let's start with the first one, prototypal inheritance. Okay, I think if you write JavaScript, you know it's prototype. It's used prototype, right? There's no like a real class. There's no real class. It's not real like what is that? Class-based inheritance. Okay, so the basic idea is in JavaScript, every object has a special property called prototype, which link to another object. So this is very important. So every object has a prototype, right? And there's a link, the hidden property. Yeah. Even say you say const object equals this, you see actually there is a proto. Yeah, this is one, right? And any object has this one. So this is a very important one. It's proto. It's very it's hidden, and it's actually a prototype, but for some historical reasons, it's proto is actually the proto could be used. Actually, there's another method. Okay, historical getter setter. Yeah, actually, we'll talk about this proto later. For now, we will remember that for every object, there is a hidden link to a hidden property linking this object to another object. That object is called prototype object. Okay, like every son has a father, something like this. Okay, say if we create an object like animal and a rabbit, if we set it by hand, manually set the proto animal, you see when we call rabbits eats, even though the eats is not defined as a rabbit, it's still it the eats could be accessed, right? The eats is actually on the animal, so that's that. By that we know that for JavaScript, if you access something, if the property is not on the object, it will search the property on its prototype, right? Well, animal, because for now rabbit's prototype is animals and eats is on that, so rabbit eats, well, it's true, so it could be accessed, right? Yeah. So you see that this is the, and besides animal could have its own prototype, right? So actually this will be a chain of prototype, right? Object and its prototype, and this product is this prototype is an object, and this object again has the prototype. There will be a lot of prototypes until the end will be null, right? Until there's no prototype. So JavaScript will search on the chain. Cool. So here is an example that rather than some primitive values, there might be a what? A method. Yeah, a function. Like you see, the rabbit, we say the proto animal. Animal has a walk property method. If we call walk, it can alert animal walk. So here's a problem. Here's a question. For this walk, what is the this keyword, right? This, as I've recorded a video about this. So please, you can, if you're interested, you can search on my channel for that video. Remember, for this case, if you call rabbit.walk, this walk method is actually applied to this rabbit object. So if you, even if this is written here, if you call walk, this function is binding to this object, right? So You can think that prototype is like only a bunch of properties without these. This actually is where it is used, right? It's not where it is defined. Of course, that if you use if you set walk to like arrow function, that is not another topic. Anyway, so this prototype object is just a plain object. It's nothing special. The special only the thing that is special is that the JavaScript will handle this prototype chain. Cool. Say like this, we have three objects: long ear, proto to rabbit to animal. Cool. We call longer long ear walk. It will search on the chain. Okay. Cool. There are two limitations. It could not be circles, right? Circular reference is forbidden. So okay. And the other one is other types rather than object and null will be ignored. It's reasonable. Writing doesn't use prototype. Prototype is only used for reading properties. If you set something, let's say if like this, say user like this, and there's a setter getter. Oh no, wait a minute. It means if you say something, it's actually will not walk on the prototype chain, right? If you set something to rabbit, it would modify that rabbit object directly without going to animal. Well, this is reasonable, but if you call something as a setter setter property on a prototype, like it looks like you are setting the property of a domain, but actually full name exists on the user, right? On the prototype. So actually the setter getter is a trigger, and say for this case, Alice full name is Alice Cooper. What will it do? So admin, this will be called, right? And this, of course, as we said, it only matters where it is called. So this will trigger the full name, right? The function will call this. So the name of the domain and the surname of a domain will be both set to Alice and Cooper. Remember, okay. So this is not affected by prototypes at all. We just follow the rules of how this affects the logic. Please search on my channel for this topic. Nothing special. Like here's an example. Animal has walk, sleep. It sets these to sleeping. Remember, this does not necessarily bind it to animal. It is binded to where this function is called. This function is called rabbit.sleep. So this is pointed to rabbit. Cool. So method is shared, but object state is not. Cool. That's reasonable. So for n iterates over inherited properties. I remember there is a method called the has own property. This is used for this. If you call let n, the property of a prototype like eats will also be looked up. But object keys only return own keys. So yeah, nowadays we use object keys. For n, recently I never use it. Okay. So you see rabbit has own property. Where is this has own property? Well, it's actually on the object prototype, right? Remember this actually, as we said, the object, you see, object has a proto. This proto actually points to object itself. Object, remember object, we define object like Objects like this. Objects are literal, and object prototype it should be equal to object prototype, right? It's not. It's object. My bad. It's not prototype. It's proto. So this concept is really complicated. Prototype. Oh, 4. Oh, shit. Okay, so you see, for the rabbit, the prototype is animal, but animal, we didn't say anything, so it's default to object prototype, and object prototype has a prototype to null. So this is the prototype chain. In object prototype, it has own property, but it is not. It is not in the for n because what? Because this built-in prototype is not enumerable. Yeah, it says it's not enumerable, so almost all methods ignore the inheritance property. So there's another method called object. Like object is property is enumerable. If we say no, it's like what? Like toString, right? It's not enumerable. So built-in, not enumerable. So let's summary for this chapter. In all object has a prototype property, either object null, and we can use proto to access it, or we use better method called object get prototype of object get prototype of object. It's equal to this one. Maybe this will be better because this proto is a historical name. The object referenced by is called a prototype. So it's not prototype means it doesn't mean the object is special. It means how the object will be treated is special. It's treated specially by the browser, so it is called prototype. If you want to read a property, it does not exist, JavaScript will find it through the prototype chain. Okay, write, deletion are act directly on the object. They don't use property. Assume it's a data property, not a setter. Right? Setter is a special case. If we call this still reference to object. Well, it's this logic has nothing to do with a prototype. Okay, so for n, okay. Well, that's pretty simple. Let's try answer some. I'll try to solve this some tasks. Okay, for animal, rabbit put an animal. Alert rabbit jumps. Rabbit has jumps, so this one it should be true, right? Delete it. Alert rabbit jumps. Jumps is gone, so we search on animal jumps null, so it's null. True null, and we delete animal jumps. Well, delete doesn't affect the prototype, so it's still null, right? Well, undefined. Alert rabbit jumps with delete and null. It says delete options act directly on the object. They don't use the prototype, right? Rabbit jumps is undefined, but it's null. Really? Let's copy the code. True, null, undefined. Animal. Delete could work. Well, it says delete doesn't affect the prototype, but it's actually affected. Delete. Ooh. Well, this is a little confusing. So actually, delete works on prototype. My bad. It says delete animal jumps. It's not delete rabbit jumps. Let's try to do it again. My bad. It still doesn't affect. If we delete rabbit jumps, so as we said before, it should be true, and then null, and then null. Cool. So we're not making mistakes. Searching algorithm. Here are two parts given the following object: head, table, bed, pocket. Using proto to assign properties without any property lookup for will follow the path. Well, we'll just set the proto as we need, right? Okay. This one, eat, animal has eat, rabbit has the proto of animal, rabbit eat. If we call rabbit eat, this will be set on rabbit. Rabbit, of course. Why are both hamsters full? We have two hamsters, Speedy, Lazy, inheriting from the general hamster. We feed one of them, the other one is also full. Why? So hamster has a stomach, eat this stomach. Speedy is hamster, Lazy is hamster. We eat an apple, we call this stomach, right? This is pointing to a Speedy, but stomach is not on this, so we're searching on proto. So because these two has the same stomach on the proto, so this stomach will be pointing to the same array. Cool. Actually, pretty not that difficult, right? Let's continue to next one. A.prototype means function. Remember, new objects can be created with a new, like this is the old, this is a new, the old fashion, right? New something. But now we already have a class or something. So if the prototype is an object, then new operator uses it to set the property for the new object. Well, this is the old fashion. Before the ES 2015, we created rabbit, and this is the construct function, and we set rabbit prototype to animal. Actually, this is not the typical one. It should be rabbit prototype dot something like eats blah 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 blah. Okay, so we need to pay attention that current prototype means the property of a function. It's not the prototype object. Okay, this needs to be clear. Okay, so rabbit function, because we're using as a constructor, so we call it construct function. Its prototype property is set to animal, and so if you create new rabbit from this construct function, it will have the prototype proto, right? The underlying prototype set to this prototype. Okay. Remember, the prototype of a function, prototype property of function is only used at new, right? Say, yeah. So if you create a function, create an object with these construct function, and then you change the prototype, it only affects the new one. The older one will also keep the old prototype object. Cool. So for some cases, if we don't set a prototype, we will have a default one. Default one is a plain object with a constructor set to itself. So this reminds us why we need the constructor. Well, actually, we should still remember the instance of, right? Like a class A, and we set a new A constructor. We can use constructor. It should be pointed to A, right? So it equals to A, true. But actually, this constructor is not on this A object because we didn't set it in the class. It actually is the constructor is a property on the proto, right? It says, you see, the prototype has a constructor, which is the default prototype, right? It says constructor is A. Okay, now we can say instance of A. Yeah, it's true. Now let's see if we change the prototype like a.prototype dot constructor. We delete it. Constructor. Now you see for A, we delete the constructor. There's no constructor on this prototype, but it says constructor of the object, right? So this prototype, there's no constructor, it's nothing, it's empty. Now A instance of A, it's become false. Still true. Why? Let's see. A proto constructor. I thought it is not A instance of A. Well, it's still true. This is against my. If it is about class, maybe let's try to function new function B. Const B equals new B. B constructor is B. Delete B proto constructor. B instance of B. True. Okay, forget about this. I thought that instance of is actually check on the prototype chain to search if this B exists on the prototype chain. But now it's not, right? It's not on the prototype chain, so I think it should not be true, but it is. Let's forget about it. Okay, so we actually for each function there will be a default prototype with a constructor set to the to this constructor function. This is true. This is a graph say a rabbit, new rabbit, constructor rabbit, true. Yeah, this is the constructor function. We have a prototype property pointing to this one. This is default prototype object with a constructor pointing back. When we create a new rabbit, and this prototype, the proto will be set to this default prototype, right? Yeah. It says we could change the rabbit proto dynamically. Okay, let's see. B prototype constructor. Let's set it to A. Now, if B instance of A, let's see the B's prototype chain. Prototype constructor A and then constructor. So B instance of A, false. Okay. So instance works different. Works like if once it's created, instance of will not be affected by changing the constructor. That's what I get from this test, but I thought it was different, so I made a mistake. Okay. So yeah, so in this chapter, we are taught that for each function, it has a prototype. If you set it, that will be used as the prototype for future instance, right? Remember, it only works as a new when you are creating a new object. If you're changing it dynamically, the already existing objects will not be affected. Okay, cool. Now let's try to solve these tasks. Okay. Well, it's very long. In the code below, we create a new rabbit and then try to modify its prototype. In the start, we have this code: rabbit, it's true, rabbit, other rabbits, of course, true. We add one more string, emphasize what will alert show now. We set it to empty, right? we set it to prototype to set it to empty object. So rabbits eats nothing, right? Undefined. Okay. The first one, we write it down, undefined. And then if the code is like this, we set the prototypes eats to false. So what's the eats? Wow, false, obviously. And this one, rabbits proto rabbit delete rabbits eats. Remember, prototype will not be affected when you are doing the write or delete. So for the rabbit, there's no eats. If you call rabbit eats, it still will go up to this prototype. So that's true. The last one, rabbit prototype eats true. We did the eats. Of course, the prototype now doesn't have eats if we call it undefined. So this 4 should be the solution. True, false, true, undefined, true, false. The number 1 is true. Wait a minute. My bad. As we said, it will not affect the existing one. So yeah, I'm stupid. Cool. As we there's another thing we I need to address is that about this prototype thing. We know that we could create objects like this was in the next chapter, right? Okay, let's go to the next one first. Native prototypes. If we create objects like object literal, actually it will be created with object function, right? So object has a prototype. Object actually has object. Wait a minute. Object prototype has a prototype property which points to these function like method collection. It has constructor, has owner property. Like C, there's a proto thing. Yeah, remember if we call a wait a minute. Class A. When we call proto, actually it's on the not last, the one before null. The object prototype. It's a getter from this object prototype, right? So this is not a property of this instance. It's the property of the object prototype. Okay, so if you create a new object, the prototype of its object set to the object prototype. So for array date, they are the same. If you create an array literal, the prototype will be set to the array prototype, and array prototype is an object, so it has a prototype to object prototype. So this is a different prototype chain. This is the same. This is the same. Remember, slice is array functions. Array from so sometimes we use array prototype a slice, right? To bind or call a function, we have call, right? And so for A is a function actually. Type of a function. A has call, right? So the call actually is on the function prototype. So a call equals to function prototype call. It should be true. Nothing special here. This is a chart for detailed, like what we're doing in this dev console. Array proto is array prototype, and its proto is a object prototype. Cool. Remember, for primitives like numbers, they are not objects, but if we try to access their properties, JavaScript engine will create a wrapper object to make it like an object. So you say A equals 3. Okay, I'm sorry. Num3, type of num, it's number, and num, if you want to access proto, internally there will be JavaScript engine will create a wrap this value, and you can see num's proto is to number prototype, And this prototype will be object prototype, right? Cool. So this proto, of course, is null, a primitive value, null, 0. What does this mean? Well, let's forget it. We could change the native prototypes, but it's not good. It's only used for like a party field. Cool. Sometimes we'll call the method from prototype directly. Well, this step is very simple. Okay, so now add method defer to functions. Function defer. Function defer. Well, we can just say f, because this is not an instance, we could just say defer, right? Something like this. Oh, it's not good to add to the prototype, right? Mine is better, I think. Add the decorating defer to functions. We are asked to add prototype of functions. My bad. So this is cool. Add the prototype of all functions. Defer, that returns a wrapper delaying the call by ms millisecond. Okay. So function prototype defer equals function. We're using this. Okay, for when this function is called, to call defer, 10 after 1 second. So actually it will get seconds. Set timeout. Set time defer. Okay, it will return the function. No. When you're using function, this of this function is actually binding to where it is called. So here actually we could use arrow function. These args, I'll say. So f these actually means to the f. This is set to the function. I could say args, right? And let's set of the second. Let's create a set timeout. Second. Oh, this should be 3 dot. Cool. Now, if we say f and b, f defer 2 seconds, 1, 2. Defer is not a function. Oh shit. Return the function. Again. Shit. Okay, now f defer 2 seconds, called 1, 2, 3. Okay, we're done. F this, well, because actually the arrow function will solve this problem. Cool. That's all for this chapter. Let's go to the next one, the last chapter, which is objects without proto. So the proto is an exe name. Okay, so actually we could use object create and pass it with a prototype and create a new one It's just like the before. We set the prototype manually. Okay, object rabbit, of course, animal. Object create. Okay, so actually, object create, you see, is create an object and set the prototype to that object. So what if we want to create our own object created, like const object create this prototype? What should we do if we don't use uh, if we don't use object create? Well, of course this is simple. We could say const like object, right? We could say object set prototype of object to prototype and return object, right? Oh, I'm sorry. Function. You see object create const a create b equals 3. Ooh, God. There's typo everywhere. This type prototype. Const a equals object b3. Let's see what a is. They set prototype to b3, yeah? And of course, we have another way to write it. If we use the old-fashioned function way, we said we can create a function called function, right? F. We could set f prototype equals prototype, right? And we could return what? Return a new f. This is old-fashioned. So let's say const a equals create b3 a. What is a now? Proto 3. Yeah, it's the same. Okay, object create. Object create has an option second argument property descriptor. Well, I have never used it. I have never used this before. Actually, we could just to define specific properties of these detailed like settings for these properties, whether they are enumerable or not, if there's frozen or settable, gettable. Yeah, that's very fun topic. Okay, so this is a recap on the Proto's history. So prototype actually change the prototype existing object actually will breaks the optimization of internal logic of JavaScript engine. So don't do that. Let's take an example here. Create an object. We set object proto, but actually the proto will be, it's a special property, will be ignored. And you see object key doesn't have in object actually proto is not there because this proto will go to the object's prototype, right? That's we said before. Oh, sorry. Let object equals this object's prototype actually equals to object's prototype proto. False. Why? Wait a minute. The prototype actually is the get. My bad. This is not true. It means The prototype actually is called this. It's a get prototype of object, a prototype. So if we cut down the prototype chain by setting a prototype to null, we can set the proto as a normal key, right? Cool. So the chain will be shortened like this. You could just create null to create a very plain object without proto, or stick to map. Right. So that's all. And another topic is extend, right? You see, we know that class like class A actually is just a syntax sugar, because actually it's equal to the function way, right? It's just a different way to write it. So what about like class parent? Let's say there is a parent call parent method. We log a parent method, and we have a class child extends parent child method console log child method. Okay, now create a child. What's a new child? Let's see the prototype chain of child. The first, the child proto go to parent, right? And we have a child method, and the constructor is child, and its proto equals to parent's prototype, right? Oh, the here actually it says maybe the last one. Let's see, child prototype equals to child prototype. True. Yeah. What does this parent mean? It means the last one? Maybe. So it's not equal to parent prototype, right? Yeah, but child's proto equals parent prototype. True. Yeah. Child instance of child. True. Child instance of parent. Yeah, true. Parent. Unexpected identifier. Child parent. Instance of it's lowercase. True. So we see if we're doing extend, actually the instance will be first has the closest prototype from the constructor function, and then it will that prototype will be set. Remember that prototype will be set to the parent, the one level up to that prototype, right? So there will be a prototype chain. So how could we do this in a function way? Let's rewrite it. If you want to write our own extend, how we do it? Let's say it's a function b parent. Parent prototype. We have a parent method function console log parent method and function A. We need to extend it, right? So how could we do it? Let's create our own extend. Const extend. We accept a constructor which is f to, like, say, child to parent. What we gonna do? Well, as we examine the prototype chain, we need return a function which it has a prototype set to the parent, right? And the constructor will be child. Wow, cool. So actually we'll say child prototype. We set it to dot proto equals parent dot prototype, right? Okay, let's see if we can do that. We can use object set prototype of child prototype, sets the child's prototype to a parent prototype. Wow, this is very simple, right? And then I think it's done. Now let's say if there's a function called a child prototype. And now we extend it. Extend child parent. Cool. Now we create a child. Now we analyze examine the child's prototype chain. Child proto, its child method, cool, and then its proto again points to parent. So this child still have child method, right? And have parent method. Cool. So we can create our own extend by this means. Yeah, so that's all. Let's try to solve this task. Add a string to dictionary. Create it. Okay. Add method to string. You should return a common displacement. Okay, so proto is regular property here. Alert dictionary. Dictionary. We could add a string to it, right? So it should be something like what is it? Object set, like set property something. Object create. Rewrite. I see. So actually there's like object set property. Set what? No, where is it? Define property. Yeah, we can use define property and add the toString there. Difference between calls. Create a rabbit. Okay, say hi. Rabbit, what does this call? Same or not? Okay, rabbit say hi. Rabbit say hi. We'll call to the prototype say hi. So this name, rabbit. So it says rabbit. Second one, rabbit prototype say hi. Wow, say hi is this function. This is called on prototype. Prototype, there is no hi on prototype, so it's undefined. And then get prototype of rabbit, which means this prototype say hi. Still, it's prototype itself. There's undefined. Rabbit prototype say hi. Still prototype, right? So rabbit 3 undefined. Cool. So that's all for prototype and inheritance. So actually, after reading these fantastic materials, the concept between I think, pretty simple. Remember that all the prototype objects, there's nothing special about them. The only special thing is about how JavaScript handles them. There are how to say it? There are several important concepts of why prototype is important. The first one, every object has a internal prototype. Every object has that, and that generates a prototype chain. JavaScript, when access some property of object, if it doesn't exist directly on that object, the JavaScript engine will search on a prototype chain. If there is, it will use that value. Well, there's nothing special about the values. If the value happens to be a function, that will be will be used as a normal function. But for function, there's another set of logic about these. So if you call instance dot the prototype method, actually these will be binding to the instance itself. Well, that's not about a prototype. It's about a function. These, it's about lexical scope or something. Yeah, and for function, function has a prototype property, namely prototype. So that is only used for when the function, for cases like the function is used as a constructor function. It was only used for that case. If you change the prototype later, property later, it will not affect the instance object, right? And yeah, so and the JavaScript has a lot of method about prototype, like get up prototype, set prototype, and we have object create that you passing object up prototype object, and yeah, that's pretty all of it. And the internal built-in methods of prototype, like objects or array, they are all enumerable, so you cannot get from for in. And as we demonstrated, for class, it's just another way to write the. It doesn't change the logic; it's just a way of writing it. Another way of writing, rather than the old-fashioned function dot prototype something. And the extends actually will only what will it do? It will just create a function with a prototype. Prototype sets the parent prototype. As we demonstrated, we can write it by ourselves. And that's all about prototype. Yeah, pretty easy, right? Although this JavaScript info is really good at reading materials, I'm planning to read all of them. I still have like 2 weeks to prepare my interview. Yeah, that's all for this one. Yeah, thanks for watching. See you next time. Bye bye.